Good evening, sir. So this is our video for our final review of our project on wireless communication networks, and our topic is performance analysis of virtual private networks. And our team consists of SHASHANK, me, MEHUL, RISHIK, and ARNAB. So this is the system design that we have proposed, and we have also simulated this exact system design in Cisco Packet Tracer. So in our project, what we have done is we have used several of encryption algorithms, and we have done an analysis of the performance of all those encryption algorithms. And finally, we have tabulated the results, and we have given a conclusion based on our results. So this is the environment setup, and now Arnab will tell you more about our environment topology.
Good evening, sir. So, sir, this is the environment setup with what we have done. So, we have taken three networks: network 1, network 2, and network 3. So, in this, we can see that between network 1 and network 3, there is an IPsec tunnel where our VPN has been implemented, and there is no IPsec tunnel between network 2 to network 3 or network 1 to network 2. So, we can also see that each network we have given a PC, a router, a server, and a switch. So, all these have been configured accordingly, and these configures will be further explained by Mehul.
Yes, sir. So as Arnab has already explained the environment setup, I'm going to move on to the VPN setup process. So I've done this in three parts. So in part one, I have enabled the security features like the key distribution method, the encryption algorithm, the hash algorithms, and the authentication methods. And finally, I have done the IPsec parameters configuration on routers 1 and 3. And then I have verified the IPsec VPN using the terminal commands on the following routers. So this has all been done on the Cisco proprietary router 2911 integrated services router. So these are the commands that I have run on both the routers, router 1 and router 3, and I have set the policies, security policy 10, which is by default set, and I have set the encryption as AES. The key distribution method has been set to ISA-KMP, and the hash algorithm being used here is SHA1, which is having a default 160-bit hash, and the authentication method is pre-share, and the AES algorithm that we have used here has default 128-bit block in this router. And finally, we have configured the IPsec parameters using the transform set, and then we have just used the crypto map VPN map command to map all the settings that we have provided onto the routers. And this is basically the table along with the details of all the components that we have put in. So now I'm going to show you that the tunnel has been established between routers 1 and 3, which is connecting networks 1 and 3, and it is secure, and the encryption and decryption is also taking place. So I'm going to just ping packets from network 1 to network 3 PC. So initially it takes some time to get it started, but after that the connection is consistent. So here we have sent approximately eight packets, and now we are going to the router. And in the router, I have already run the command show crypto IPsec SA, which gives the stats. So initially the stats is 00, and now once I run it once again, it will simply show that the encrypted packets is 6 and the decrypted packet is 5. So here you can see that when I send packets from network 1 and 3 along the encrypted IPsec channel, we are having some sort of encryption and some decryption, and that was our main aim. Now what I'm going to show you next is that if we send some packets from network 1 to network 3, the packets will definitely go, but there is no encryption and decryption taking place. So now I will again run the same command in the router and see if there is any encryption and decryption. So here you can see the encryption and decryption remains the same. So there has been no packet encryption and decryption. So the packet can be easily sniffed by attaching a sniffer, and that will be further explained by Rishik.
As Mehul said that there is a encrypted tunnel between router R1 and router R2, and the network 2 is unencrypted. So if we ping or send a ICMP packet from through the encrypted network, the third party should not be able to sniff that. As in the case of public Wi-Fi, we can sniff the packets and we can see what the person is browsing on the internet. That should not be the case. So if we send any packet through ping ICMP packet from PCA to PCB, it will show ICMP in the sniffer buffer. But if we ping from PCA to PC A of the another network, that is 192.168.3.3, it will show IP6, that is the encrypted packet. So the data cannot be seen by the third party. As
So
you
as
can see
Rishik
that
already
there is a ICMP packet. He just Mehul just pinged from PCA to PCB, and next he will ping from PCA to third network PCA, that is 192.168.3.3. You can see that there are four IPsec packet, which is encrypted packet, and the third party cannot see what's in the inside the packet.
So Rishik here exactly explained what I was trying to say. Here you can see when I send packets to the non-encrypted network, the packets can be clearly seen as the ICMP packets, but when I send through the encrypted network, there is no identification and it only shows IPsec. So our aim has been established and we can show it from here. And after that, I'll proceed to the analysis, delay analysis and throughput analysis will be done by ARNAB and SHASHANK respectively.
So yes, so what we can see is the delay analysis. So we have done the delay analysis according to our with or without our VPN, and we have taken some criteria like whatever we had done during our router configuration, like AES, secret key encryption, and asymmetric packet, asymmetric one. So what we can see that without VPN, there the when we are doing it without VPN, the delay analysis is 0.0121, while with VPN, its delay analysis is 0.0331 in case of AES. Same with our secret key encryption and also the last one. So now we have also done what we have there. We have created a graph sort of format so that we can show it properly, where the x-axis shows us all the criteria we have taken in mind, and also and the y-axis is the milliseconds. And so now Shashank will continue from.
Yes, sir. As Mehul explained, we'll be using HTTP throughput analysis. So as we know, it's basically the number of items processed in per unit time. So in this, we'll be transmitting megabytes per second, and so we'll be using different kinds of encryptions like AES, which is used to implement and encrypt sensitive data, and it and the second one is the secret key encryption. So in this, we encrypt and decrypt messages so in a symmetric way, and the last one is asymmetric public key encryption. So as you can see, sir, when we are using VPN and without VPN, the following data is the maximum number is with the AES encryption, with the VPN, and without the VPN. So, sir, no, next slide. So this is the graph. As you can see, we are transmitting megabytes per second, and the ACS one will get the highest number of transmission
Yes,
as compared to secret key encryption and asymmetric public key encryption.
yes.
So, sir, at last, sir, we can say that we performed all three, but the ACS encryption was much better than the other two encryption, so we did it on ACS encryption, AES encryption.
Yes, sir. So after finalizing all the test results, as Shashank already told, we found out that AES encryption is the best method that can be used in the Cisco 2911 router that we already have in Cisco Packet Tracer. And these graphs, they have some clear differences between them, and also we have some clear sort of distinction between the without VPN with VPN. So surely there is some performance difference in that. And as Arnab also explained, uh, here we can see there is difference between the different encryption algorithms, and obviously all of us summarize that finally we got the result that AES is the best with respect to the performance, but also we know that AES is not that secure, and with respect to the security terms, other algorithms are also very good. But finally, we conclude that our performance is the best for the AES encryption algorithm for a VPN. So thank you, sir, for this presentation.
Thank you, sir.
Thank you, sir.
Okay, sir.